in this part. Now let us find out values of alpha 1. So C1, alpha 1, alpha 2, 1, alpha 3, 1 we need to find out. Let us go to the formulation which we have. So in equation 8 and 9 we have recursion formula to obtain alphas. So let us copy this and paste it here. Okay, so now we have formula of alpha. Also we need to have values of not vectors, which are equation 14 and 15. So let us copy them and put below it, so we can simultaneously compare the values of I and j. Now for calculation of this Cj, we used I, which was in the range 1 to 2, which was 1 to 2, and j was in 1 to 4. So that was for Cj. Now for alpha, let I is equals to 1 and j is equals to 1. So that is, if y1, we need to check this, y1 belongs to in between xi, which is x1, and xi plus 1, which is x2 now, because I is equals to 1. Okay, so if this condition is satisfied, then we have value of alpha, okay, from equation 8. The value of alpha 1 comma 1 will be equals to 1 if that condition is satisfied. Otherwise the value will be 0. Okay, so we need to check this. So for current case, we have situation as, for the given case, is 0, which is a value of y1, and x1 and x2 are to be compared. So if it is greater than or equal to this 0, and also it has to be less than this 0. So this condition is not satisfying because 0 cannot be less than 0. So that's why it is a failure. Therefore we can write now alpha 1 comma 1 as first order is equals to 0. Let us change this style so that it's a final value, we can use it for further reference. Okay, so now for, let us increment I, which is equals to 2, and j keep it same, which is 1. So that is, we are trying to find out, check whether y1 is less than or equal to or greater than or equal to x2 and less than x3. So is whether it is in between x2 and x3. So here for the current problem, again y1 is 0, x2 is 0, and x3 is 2. So is that a fit? Yes, actually it is. So that's why now the value of alpha, which is I, is 2 and j is 1. So 2 comma 1 is unity. Again, now increment I. For I is equals to 3, again check whether y1 belongs to in between x3 and x4. So if this is satisfied or not. So y1 value is 0 and this is 2 and 4. So 0, this is a failure. So for this reason alpha 3 comma 1 will be equals to 0. So this is the way we can obtain the values of alphas, especially of first order. Second order, we need to use again recursion formula. Okay, so we need to always check whether x1, x2, x3 and corresponding y1 values where they are lying. Okay, so now for this reason alpha 3, 1, 4, 1, 5, 1, all values are 0. Condition is failed. So now for z is equals to 2, we are referring to y2 now, because for z is equals to 1 in earlier case it was y1. So now we are trying to say y2, whether it is belonging to which region. So if we look at the vectors, we know that y2 is 0 and it naturally belongs in between x2 and x3. So that's why this is x2 and x3. So we can directly write this relation as 2, 3, 2, 2 is unit value. For I is equals to 2 and j is equals to 2, alpha is unity value. For all others, again we need to check. So for 1, 2, 3, 2 and 4, 2, 5, 2 also, all these values are 0 because they are not satisfying the relation. Okay, for j is equals to 3. Okay, let us change this style since it's a final answer. Okay, so this is 0. For j is equals to 3, so we are referring to y3 now. So where it belongs, y3 is 1, so again it refers to in between x2 and x3. So natural, this is x2 and x3, so that's why we can say alpha 2, 3 is unity now, and all other values 3, 3, 3, 4, 3, 5, 3 are 0 because the condition fails there. Okay, now j is equals to 4. Let us recheck it, y4 where it belongs to. So y4 value is 2, so naturally this belongs to in between x3 and x4, 2 to 4, because it is equal to 2 and less than 4. So this condition is satisfied, so naturally in this case alpha 3, 4 is a unity value.